All right, here's number 49. Shh. Find the acceleration reached by each of the two objects in this diagram if the coefficient of kinetic friction between the 7 kilogram object and the plane is 0.25. All right, so we have friction here. The only object that has friction is the guy on the incline. This guy over here is just hanging there. So how do we start problems like this? Free body diagram. All right, let's just get this ready. I'm going to do the free body diagrams right here. So this is 12 kilogram. I'll make note of that in a minute. Just kind of clear this up. Get rid of that. Okay, so let's start with the 12. So this guy right here is 12 kilogram, and we'll call him M2. The 12 kilogram guy will be M2. This guy over here is M1, and he's 7 kilograms. Okay, get this rope. Okay, so let's start with M2, the hanging guy. So what are the forces on M2? How many are there? 2. We have mg down, but you got to say m2g, right? Don't just say mg, because you have two masses. You got m1 and m2. And then the other force on m2 is tension. There's no normal force on this guy because he's not on a surface. Okay, so there's just those two forces. All right, going over here to m1. What are the forces on m1? Well, we have m1g pointing down. Thanks. So this right here is m1g. We have tension pulling up the hill, like that. We have a normal force, which is always perpendicular to the surface. So that's Fn. And they told us that friction is present. So which way does friction point? Opposite motion, parallel to the surface. So which way is M1 going to be moving? Which way does M1 move here? It's going to be moving up the hill, right? We've got 12 kilograms here and 7 kilograms there. M1 is going to move up the incline. So if the motion is up the incline, which way is friction? Down the incline. Friction is always opposite motion, parallel to the surface. And friction equals coefficient times normal force. All right, so a couple things. For objects on an incline, to simplify the situation, you want to tilt the xy axis. So you want to say that the incline is the x, and perpendicular to that is the y. So this will really simplify things. Okay, the other thing is for pulleys, the sign convention has to round the pulley. So you always want your acceleration to be in the positive direction. So you know, which way is M1 going to accelerate? Up the incline. So let's say that up the incline is plus, and then down the incline is minus. That's going to be our sign convention for the x direction. Now what happens to that sign convention? That sign convention wraps the pulley. So over here, what are we going to have? Down is plus, up is minus. Does that make sense? The sign convention goes like this. It goes positive, 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 positive. It's all one motion, okay? The acceleration is positive for both objects. Okay, so the thing remaining to do here is we got to deal with mg. Now what do we notice about mg for m1? What do we notice about this mg here? Does it point perfectly x? So here's the x direction for m1. Does mg point perfectly x? No. Does mg point perfectly y? No. So what do we have to do to mg for m1? Y component, x component. You got to break it into components. And then this angle in here is always the same as the angle of the incline. So that's 37 degrees. Okay? So now the problem is, the free body diagram is set up, and we're ready to, what comes after the free body diagram? Summing the forces. So we're going to sum the forces for M1, X and Y. And then we're going to sum the forces for M2. Okay, for M1, how many forces, so focusing just on M1 here, how many forces are in the X direction? So here, this is the X direction. We tilted the XY axis. How many forces are in that direction? 3. We have tension, we have friction, and we have the X component of mg. Those are the 3 forces, X. Okay? So we're going to go tension, that's positive, points up the hill, minus friction, friction is mu Fn, and then minus this guy, which is the X component of mg. How do we get that X component of mg? Sine 37 m1g. Okay, so this is going to equal m1a. The sum of the forces equals ma. Okay, in the y direction. Yo, did I make a mistake? How to do this? Okay, there's 3 forces in the x direction. So for M1, for the object on the hill, this is the x direction. The incline is the x. So we have 3 forces in the x direction. We have tension, which points positive. We're saying up the hill is positive. We have friction, which points negative. So that's this guy right here. And then the other force we have in the x direction is this guy, which is the X component of mg.
And that's negative?
It's negative because which way does he point? Does he point up the hill or down the hill?
Down
Down
the hill.
the hill. Down the hill is negative. Okay?
And
then
why is it sine and not cosine?
well, because 37 degrees is right here. So there's 37. This component that I'm circling is opposite the 37. And opposite is sine. Okay, in the y direction, how many forces are in the y direction? So here's the y. How many forces in the y? 2. The 2 forces in the y direction, normal force, and the y component of mg. So that's going to be normal force minus cosine 37 m1g. And the sum of the forces always equals ma. Now look, is the box, will M1 accelerate this way? Is there going to be an acceleration perpendicular to the incline? Which way is M1 going to accelerate? It accelerates this way, right? And that's the whole reason we tilted the xy axis. The whole reason we tilt the xy is so the acceleration is perfectly x. So we can take this y acceleration here, this guy, and set it to 0. Let's do that. This a right here goes to 0. Okay, let's go to M2 now. So looking at M2, remember, down is plus. So this is going to be M2G minus T equals M2A. Okay? Now, the hard part's done. We did free body diagram, we summed the forces. The rest of this problem, I would consider it to be, basic algebra. It's not that hard. So they're asking us to find the acceleration. Now, check it out. This equation and this equation have 2 things in common. What do those 2 equations have in common? T and A, right? Tension and acceleration. And when you have two objects connected over a pulley, they share those. The tension and acceleration are always the same. All right, but we're also going to have to find the normal force, because normal force appears in these right here. We have to find the normal force so we can plug it in there. So taking this equation, take this equation, solve for normal force. Normal force comes out as 54.786. Okay? So once we have that, plug it in there. So basically what you're going to do is you're just going to do a system of equations here. All right, so I'm going to take this x equation, take this equation here, solve it for t. T equals m1a plus mu fn plus sine 37 m1g. Then take this equation, solve it for t. T equals m2g minus m2a. All right, what do we know about these tensions? They're equal. So if the tensions are equal, that means that this and this are equal, right? So set those equal. So that's going to give us m1a plus mu fn plus sine 37 m1g equals m2g minus m2a. And what's the only thing missing in this equation now? A. All right, so solve for, I'm out of room, so I'm going to do this in one step. So A is going to be m2g minus mu fn minus sine 37 m1g all over m1 plus m2. So you plug the numbers in there, you plug the numbers in, and your acceleration comes out as 3.3. All right, what's the main thing? I mean, the main thing I have to help you with is what? The main thing that I had to show you was the free body diagrams. If you don't get those correct, you're done. You can't get the problem right. And then after the free body diagrams, you sum the forces. Once you're done summing forces, the rest of it is just algebra, which I think is pretty basic algebra. It's not too bad. If you're having trouble with this algebra, you know, I mean, this class should be difficult because of the physics and not because of the algebra. If you're struggling with the algebra, you know, that's a whole different problem. Okay, any questions?